Welcome to Everything is Changing. In each episode, we focus on circular economy, ecosystem restoration, energy transformation, sustainable mobility, and water resources. I am Ahmetcan Uzlaşık. Perspective is everything, and everything is changing. In this episode of Everything is Changing, we are joined by Dr. Marius Floriancic, a hydrologist and lecturer at ETH Zurich, who leads long-term eco-hydrology research at the Forest Lab, known as WaldLab. Marius helps us unravel the old water paradox, a surprising insight into how water that feeds our rivers and forests may be far older than the storms we see. From do-it-yourself sensors made with hiking bladers to revealing the hidden dryness of forest soils, we dive into what his research says about resilience, biodiversity, and how trees tap into memory stored in water. Tune in for a rich conversation on why forest ecosystems are more fragile and more complex than we once thought, and how science planted today is meant to last a century. Marius, thank you again for your time and joining us. I really enjoyed the Old Water New Insights article that you were featured in. It was such a fascinating look into your work and your team's work, which you are doing at WaldLab, if I'm pronouncing it right. It's a German word, I assume.
Yes, WaldLab, or we call it WaldLab.
It's forest and laboratory, right, in German. And I want to start with the basics. So what is old water paradox and why it has puzzled water scientists for so long?
I think for decades we had a little bit a misconception how rainfall becomes runoff or stream flow. So we typically observe, precipitation or rainfall, and then there's a flood forming in the river. And for decades or even centuries, we thought, it's clear, it's raining, we have a flood, the flood must be made of the rainfall. And what we see when we look at tracer data, tracer time series, is that this is not the case. So we have rainfall, but the dominant process is that this rainfall will infiltrate into the soil and mobilize water that is already sitting in the hill slope, in the subsurface, and pushing out this water that is already stored there for months, years, even decades, that then creates our flood pulse.
In your article, I remember you called WaldLab a scientific playground. What makes this outdoor lab near ETH Zurich so unique compared to other traditional hydrology field sites?
I think the nice thing about WaldLab is really that on the one hand, it's very close by. So we have a typical managed Central European forest dominated by beech and spruce, like you will find it everywhere in Central Europe, but based literally 5 minutes outside of our offices and labs, which enables us to do a lot of tedious work because we're close by. And this is definitely something that a lot of colleagues are jealous of, because we have this field site in walking distance. So we can do a lot of very intense measurements, sampling, and can also maintain this throughout the year and not only during the growing season. I think this is a very unique opportunity. The other thing that it also aims for interaction with the broad public. So big emphasis is put on bringing scientific knowledge as quickly as possible to the broad public. And so we give these public tours there, can spread this knowledge. And we can also interact with practitioners, foresters coming to our site to learn about the recent findings that we get from our research. And this allows us a very direct connection between scientists and also practitioners to hopefully get a lot of our scientific knowledge quickly into also management and praxis.
I remember in the article you even said that you could see the field from your office's window, right? If I'm not mistaken, that close. Yeah.
Yes, that's true. That's true.
That's amazing. And that I'm sure that gives you a lot of advantage on many issues. One striking finding that I think it was in the article is that even at shallow soil depths, most of the water is months or years old. What implications does this have for we understand forest water cycles? And even for maybe managing forests in the face of the climate change?
The interesting thing that we found is that even in the shallow layers of the soil, most of the water that we find there originated from precipitation in the winter half of the year. And this is first look a little bit surprising because Zurich typically receives around 60% of precipitation in the summer half of the year, only 40% in the winter half of the year. But when you think about soil water recharge, it's much more efficient in winter compared to summer. Winter, when you get 10 millimeters of precipitation, most of this water will eventually end up in the soil. However, in summer, when you have the same 10 millimeters of precipitation, a lot of the water will be intercepted, kept back in the canopy, on the leaves, and then have the possibility to evaporate back to the atmosphere. Can also be kept in this layer of organic matter, the leaves and the deadwood on the forest floor, where also the water can get stuck and then evaporate back to the atmosphere. So overall, in summer, from 10 millimeters of incoming precipitation, you will only get maybe 2, 3, 4 millimeters of this rain really into the soil. And this is why it's very important. These winter precipitation events are much more efficient in recharging soil.
In the article, you were also mentioning some do-it-yourself measurement tools. Can you walk us through some of these creative do-it-yourself measurement tools that your team uses and why you had to invent new techniques for this kind of research?
So a lot of the sensors for typical things like measurements of precipitation, groundwater level, things like these are existing. But as soon as you want to reach out and do new things, there's a lot of unintentional use of this equipment. Right? And it's very handy now with the development of these microcontrollers that you can also build a lot of these sensors on your own. For example, we use these hiking drinking water bladders, camelbacks that you typically use during hiking for drinking. And we attached pressure sensors to these and put pieces of dead wood on these camelbacks to basically get kind of a scale, and you can measure the amount of water that is stored in this piece of dead wood. And what we found is quite unique, that this dead wood, which is a porous medium, can take up water from dew and fog deposition during the night and then release this water again during the day. So we get this diurnal cycle of water in these deadwood pieces in the litter that contributes to humidity within the forest. And this is what you can also feel when you walk through the forest, right? That it's a very humid sub-canopy atmosphere. And this we found out with these, for example, homemade devices.
Your research also suggests that forest soils are much drier than we previously thought, partly because of how much water gets trapped or evaporates before it reaches the ground. How might this change how we think about forest resilience and drought risk?
So what we found is that typically, and this is I think very similar in most forests across Europe, that incoming annual precipitation, around 20% are retained in the canopies and evaporate back to the atmosphere. But then doing these experiments with litter layers in the laboratory in the field, we found out that an additional 18% of annual precipitation are actually retained in this organic matter on the forest floor and evaporate back to the atmosphere. So just comparing outside the forest to inside the forest, we cut precipitation by almost 40% already. So forests then get only 60% of the precipitation compared to the outside the forest locations. And this makes, especially here in Zurich, this means that we only have 600 millimeters of precipitation, which is typically a very dry site. So on the one hand, this interception in the canopy, in the litter layer, that plays an important role in decreasing the amount of soil water recharge. But then also, of course, trees use up a lot of this water again, right? So the trees take up this water, and you also have these consumers, big consumers in the forest that use up a lot of water.
When we come to the diverse forests, you indicate that mixed species and rich organic soils, when we have that in the forest, it's better at storing water. What practical lessons do you think your research offers for, in that sense, forest management and even for maybe biodiversity conversation?
I think the key role in the ecosystem comes to the soil, right? Soil formation is basically dependent on organic matter. The more organic matter we keep in the forest, the better soils we will have. Soil formation depends on this input of organic matter. This is the key thing that also drives then biodiversity, because there's a lot of microbes and fungi that use this organic matter to decay, and then we build up larger storage capacities that will also help us to store more water sustainably through dry periods. And then from a water perspective, of course, I would argue that when you have a closed canopy, then you keep a lot of this humidity inside the forest. And this humidity that comes from evaporating from, for example, these little layers or from that will decrease the atmospheric demand within the forest, therefore also help trees to withstand these periods of high atmospheric demand, of high temperatures much better. And when it comes to the diverse forest, as a hydrologist, I would always argue for also thinking about tree diversity in the forest according to the rooting depths, right? There's some trees that have very shallow roots, some trees that have very deep roots, and I think we should also consider these different rooting depths, because if we avoid competition for water resources in different depths of the soil, then I think it will be a much more sustainable growth in the forest.
Finally, the wild labor is designed to last 100 years. What long-term questions do you hope future researchers will be able to explore there, building on what your team has started?
I think that most of our experiments are designed for a longer time period. I acknowledge that I might not survive what I started here, but I think it's a very interesting project that allows us to start this long-term data collection and also maintain these measurements into the future. And of course, we're all worried about climate change, about the effects of climate change. And such a long planning horizon gives us, of course, a very good opportunity to also address these long-term challenges that we will face in future climates.
Thank you very much, Marius, for your time and for answering my questions. And I advise everyone to read the article that you were featured, which we are going to publish in our website also. So thank you again, Marius, so much.
Thanks a lot for having me.
That was Dr. Marius Floriancic from ETH Zurich, sharing insights from WaldLab and the forest water cycle that quietly shapes life in Central Europe and beyond. If you enjoyed this conversation, follow Everything is Changing for more interviews at the intersection of science, adaptation, and life on a changing planet. Do not forget, perspective is everything, and everything is changing. See you next time.